Yeah, I have started the live. You can present.
Yeah, thanks, Vignesh. Thanks. Okay, so good evening, everyone. So welcome to the CT challenge session. Right, so I'll be sharing my screen very soon. This time it's again going to be in Mentimeter. The entire thing is going to be in Mentimeter. So I request you all to enter your email address and name. Otherwise, you won't be able to track your responses. So don't ignore that step where you have to add your name and email address, and your email address should be IITM online degree email address. So, all right. So, I hope my screen is visible. Right. So you can go and log on to menti.com and use the code that is given here. Please enter your email address positively. So where to enter, you can see the instruction there, www.menti.com, and you have to use this particular code 8425444. Okay, I'll just give you a couple of minutes so that you can all log in. So please enter your email address without fail. That's a very important step. Otherwise, you won't know who has answered what. Again, to those who have joined new, please enter your email address and your name. That's a must. So to those who have joined new, please log on to menti.com and use this particular code to join 8425444. I see that 16 participants have joined. Once it reaches 20, we can get things started. Okay, we have few more new participants. Please log on to menti.com and enter the code shown below. We'll be starting very soon. 8425444. Okay, so I think now we have about 20 who have registered. So we will go ahead. Right, so welcome to this challenge session. So the plan is as follows. If you had attended any of the previous sessions, it's very similar to that. So this time we are going to have 10 questions. Okay, so 10 challenges. We'll have 5 minutes to try out each question, and the solutions will be discussed right after that. Okay, so right after each question, we'll be discussing the solutions. So the small difference this time is that we'll have most of them will be MCQs, but we'll have some questions where you'll have to write the code, right? So this is more like fill in the blanks, or it may be a numerical answer type question where you'll have to enter a value. Okay, so the instructions have two tabs open: WebEx for seeing the questions, because once the questions are displayed, after some time they'll go off and you'll have to enter the code or enter your correct option. So the question won't be visible at that time. And then use Mentimeter for answering. All right. So these are the two instructions, main instructions. And this time we also have a leaderboard. I think last time also we had one. Okay. So few more instructions. Whenever a problem appears on the screen, you'll have 5 minutes. Please note down your answer to the question. In case of fill the code, please note down the code somewhere in a piece of paper, right? So if it is a numerical value or a code that you need to fill in, please note it down in a piece of paper. You'll be given 30 seconds when the slide moves on, and you'll have to enter your answer within that 30 seconds. Okay, so that is the plan. All right, so those who have come in, please log on to menti.com and use this particular code. We are now moving to the first question. So this is problem 0. We will index from 0 this time. So we'll have problem 0 to problem 9. And this is fill the code kind of a question. So please read the question. If you have any doubts, post it in the chat. Please don't post the answer in the chat by any chance. Okay, so there will be single line or multiple lines of code. Okay, there'll be single line of code, and Hariteja, you won't be able to answer now. That's what I told you. You have to note down your answer in a piece of paper. When I move on to the next slide, you will be able to answer. Okay, so the last instruction is uh, when you see avoid all unnecessary spaces in your answer. That is, I mean, if I tell anything more, I will be giving out the answer, but wherever possible, avoid the use of extra spaces. The line outside, right? Whatever line is there outside the if block, that will give you an idea of what I mean. Leave exactly one space before and after the operator. That will, if you look at the next line, that will give you an idea of what I am talking about. Well, not exactly intending, but yeah. So one more minute before I move on to the slide where you can enter your answers. So whatever piece of code you have come up with, please note it down on a piece of paper. You'll have exactly 30 seconds to enter the answer. Okay, so time's up. I'll be moving to the slide where you can enter your answer. So please note down your answers. Right, so here, if possible, enter your proper name. Nicknames are also fine. All right, I'm starting the countdown now. You have exactly 30 seconds. So avoid spaces before and after your answer, right? So please avoid that, otherwise you'll get the wrong answer. Last 2 seconds. Okay, so the correct answer is d of e equal to 0. Some of you seem to have given that answer. All right, so let's see. Some have given d of e to be 1. Okay, so we have 5 of them on the top: Pritika, Hariteja, Sujit, Janani, and Debasmith. Okay, that's nice. So let's move forward and see why this is the right answer, right? So, I mean, I don't have much of an explanation here apart from the fact that we are going through each element E in the list L, right? So, notice that inside the for each, we are incrementing D of E, right? So, this can happen only if the E is present as a key in D. All right, so we have to check if E is a key in the dictionary D. If it is not a key, then we initialize D of E to be 0. Okay, so that was the missing line. And so you don't set D of E to be equal to 1, right? So if you set D of E equal to 1, what will happen is that you will count the particular element one extra time. So you'll have to start from 0, and anyway you are counting, the counting is happening outside the if block, right? So I hope you got it. So some of you, if you have written d of e equal to 0 without having this space on either side, then you might see that you got the wrong answer. So that is what I meant when I said that there must be exactly one space before and after the operator, right? All right. So is that fine? Shall we go on to the next question? Unless there are no other comments on the chat, I'll just move on. Okay. So there is, yeah, thank you. I will move on then. Okay. So problem one is coming up. Again, you have 5 minutes. Please read the question and let me know if you have any issues. Meanwhile, I'll be answering some questions on the chat. Yeah, so if you have spotted it for the first time, we'll anyway add one, right? So we'll add always. Note that this d of e equal to d of e plus 1 is not inside an else block. It is, if it were inside the else, then that's different, but it is not inside else, right? All right, yeah. So if any of you has any questions about the first problem, please remember that question. We'll get back to it at the end if you have any issues. So does anyone have any issues with this question? Any doubts regarding the problem statement? Please post them in the chat. It is not a multi-select question. It is a single option correct, MCQ only. So to Harshavardhan, think about the corner cases. Then that multi-select confusion might disappear. Yeah, so Ayush, the link will come in the next slide. There is no link. You'll have to answer using Mentimeter itself. After 5 minutes, I mean, after say 1 or 2 minutes, 2 minutes, we'll be moving on to the next slide where you can submit your answer. Please note down the correct option according to you. You'll have to select that in the next slide. So last 2 minutes, please note down the correct option. We'll be moving on. Okay, so last 30 seconds. Hope you have all noted down your answers. Okay, we are now going to move on. The countdown starts. So yeah, nearly everyone has responded, but for some five of you, I think all of the others have responded. Oh, that's nice. So we have nearly everyone giving the correct answer, but for three. All right, so let's quickly go over the solution. And before that, we have the leaderboard. Okay, so I think the top five have retained their lead. That's good. Few more have come onto the leaderboard. That's interesting. Okay, so let's now move on. Right. So the basic idea behind this solution is to look at these three consecutive elements one at a time. So we start with the first three from the left. Okay, so 1, 3, 4. We check if they form a Pythagorean triplet. So you can see they do not. So we have to move to the next set of three elements. So that is 3, 4, 5. And as you all know, 3, 4, 5 is a valid Pythagorean triplet. So we increment count by 1 there. Next, what happens is we move to the next set of three numbers, three consecutive numbers, 4, 5, 12. They do not form a triplet. So we move on and we end up with the last possible choice of three consecutive numbers from the list. They form a triplet. So we have two, right? So for those of you who still have uh, a confusion regarding what first, rest, and all this is doing, think about the same list. Okay, so L is the entire thing starting from 1 all the way till 13. Okay, that is L. So if you want to get the first element of this list, then that is first of L. That is clear. Now, if you want to get the second element of the list, then we have to go to rest of L. So that will remove the first element from our purview. So if you take the first element in rest of L, that will give you the second element in the entire list. Okay. Now, if you want the third element in the original list, what we do is we take rest of L, right? So that will remove the first two elements from the original list. And if you take the first element in rest of L, Then you have all three numbers that you need, store them in X, Y, and Z, right? And that completes your code. So X equal to first of L, Y equal to so on and so forth. And you check if it's a Pythagorean triplet. If the condition evaluates to true, you increment count and you end it there. So I have a question for you all, follow-up question. Can anyone tell me why we divide by n minus 2 here? You can post it in the chat, or maybe if you want to unmute and speak, you can raise your hand. So can someone tell me why the denominator is n minus 2? Any answers in the chat? Okay, I have, okay, Hariteja, yeah, that is right. All right, so that's the, yeah, that's correct. So the sample space is n minus 2. We can only choose, yeah, so Deba Smith, I will send you a request to unmute. You can now explain, maybe if you want.
Yes, sir. So because we are selecting a triplet, so
Okay.
if we select element number 1, 2, 3, that's our first triplet. In this case, 1, 3, 4. Then
Okay.
we move to 3, 4, 5. And when we reach towards the end of the list, we have to stop at n minus 2 as the first position, because after that there will be no. We will basically end the triplet. So that's why we have to stop at n minus 2. So our sample space is n minus 2. So that's why that's the
Great. Okay.
denominator. Yeah.
Great. Right. So yeah. So I just want. So the reason for having this particular question is that in some ways this links your statistics and computational thinking, right? So whatever code we write is not some kind of random thing, right? So if you in a statistic scenario, if you want to compute some probabilities, then, and if you don't know the exact size of your list you are dealing with, then this is the computational way of arriving at that probability, right?
Sir, we
So,
had this same question today in the statistics challenge, 1 by n by 2. Yeah.
oh really?
Yeah, just today, this morning. Yeah.
Oh, okay.
Yeah.
That's a coincidence. Okay,
Yeah.
nice one. Okay, thanks, David Smith. Am I pronouncing your name correctly? Okay. Oh, I think you have unmuted yourself. Okay, maybe we'll get back. All right. So we will. Yeah, thanks. So we'll move on to the next question. That is problem two. We have already completed 0 and 1. Problem two is up. 5 more minutes. We are starting at 6:30. 6:35. We will close. So please go ahead. If you have any questions, post it in the chat. Okay, good point, Bhavana. So I didn't give the question statement. So what we want you to do is fill that code so that uh, if you execute this pseudocode, you will get some matrix A as the output. So that A we want it to be this 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be the output of this particular pseudocode. I mean, when you execute the pseudocode, the final matrix A that you obtain must be of this form. So if that is the case, what should go into these hidden lines here? Priyanka, where do I submit the answer? See, you'll have 5 minutes to solve the question. When we move to the next slide, you can select the correct option. So please, if you have already solved the problem, note down which of these four options is correct. When we move to the next slide, you can enter your answer. So is A initially empty, right? So you can, for a hint, you can refer the first line of the procedure. First line of the procedure will give you that hint. Is Yeah, no issue. So see, Chandrasekhar. So the first, the question is you are supposed to execute that particular pseudocode and get this matrix A as output. Which of these four options, if you plug into this blank space here, will give you this matrix as output? As a hint, uh, for the initial state of the matrix, you have to look at the first line of the procedure. So the answer will be yeah, you have to log into Mentimeter, menti.com. When I move to the next slide, you will be able to select the correct option. So please note down whatever option you have selected. We have like 2 more minutes when I'll be moving to the next slide. Yeah, and Bimlesh has shared the details on the chat. You can use that. Okay, so does anyone need more time? If you need more time, please post it in the chat. If not, I'll move to the next slide. Okay, so I think we can move on then. So just 10 seconds. Note down the correct option, we can move on then. All right, so I'm changing the slide now. And we start the countdown. Okay, we have some 42, 43 respondents. The time's up. Okay, so there is a small confusion between option 3 and option 4. Some 8 of you think that it might be option 4. So but most of you have given the right answer. So let's see how the leaderboard looks now. Okay. Okay, again the top 5 retain their lead. That's good. Okay, so I'll so multiple options is in this case it's not possible. I'll just go over the solution and we'll see what is happening here. Okay, so when you create matrix, when you run this procedure, create matrix with 3 comma 3, you end up creating a 3 by 3 matrix with all zeros, right? So this is something you must be familiar with. We have been doing this from week 7, right? So whenever you create a matrix with n comma n, it will create an n by n matrix with all zeros in it. Okay, so but those of you who still have some confusion regarding what is the first index and what is the second index, note that the first index in aij, that I part always refers to the rows and the j part refers to the columns, right? So when you write aij, the first is for rows and the second one is for columns. Okay, so in this case we want this particular output. So you can see that we are moving along the columns. So we start with 1 in the first cell and then we move to the second column, we enter 2, third column 3, and then we come to the second row and we do the same thing, incrementing one by one as we go from left to right, top to down, right, top to bottom, left to right. Okay, so the columns in some sense are very critical here. So what does A00 refer to? Okay, so A00 is nothing but the first cell, row, first column. That should be 1. And then A01 should be 2. Okay, so A01 is nothing but 0th row, or depending on how you index, 0th row, first column. So that should be 2, and A02 should be 3. Right? So we can keep doing this. What we really are looking at is we are going to iterate through all the rows. Okay, for any given row, we need to go through the columns one by one, right? So, and for a given column, we have to add count to it, right? So this could as well have been written as a of ij equal to count. Okay, so nothing stops us from writing a of ij equal to count. But since a of ij is equal to 0 here, we could as well write it that way. There is nothing wrong in either of these two ways of writing it. But as someone posted in the chat, this a of ij equal to a of ij plus count will only work when a of ij is initially 0, right? So what is wrong in option 3? So let's 1 second go back and check what option 3 is. Yeah, option 3 is the correct answer, right? So the option 4 is the wrong one, as you, and I think a lot of you answered option 3 correctly, right? So option 4 is the wrong one. That's because you notice that you are incrementing count outside this loop, right? So what will happen is all the entries in a row will get the same value of count. So it will be like 1 1 1 2 2 2 3 3 3, right? That is not what we want. We want 1 2 3. So count should be inside this second, inside the second loop, right? So 3 is the correct answer, and I think you have all answered that correctly. So anyone has any other questions? Yeah, about 4. Yeah, about 4, as I just explained, count should not be outside the second for loop, right? It has to be inside the second for loop, right? Otherwise what will happen is this will be 1, this will also be 1, this will also be 1, and then only when you come to the second row will count be incremented, right? So is that clear, everyone? Okay, so there is someone asking what is wrong in the first option. I will just go back. See, first option is we are doing a of ji equal to a of ji plus count, right? It should be a of ij equal to a of ij plus count. You will understand why this is wrong more clearly when we come later, right? For the others, I'll just maybe spend some more time on this again. Note that count should be inside, this increment operation should be inside the second for loop. All right, otherwise we'll end up having the same count value for all elements in a particular row. Okay, that is not the output that we desire. Okay, so I'm moving on unless there are no other questions. We can move to the third problem, right? So you have the third problem in front of you. Again, this time you have to fill in the correct code. So take 5 minutes to answer the question. When I move on to the next slide, you can enter the correct code snippet. Yeah, so you may face problems with these brackets. So I will just give you one to all of you who are working on this. The number of left opening brackets should exactly match the number of closing ones. So please have that in mind. And the answer is just one line. Okay, so the answer is just one line. There should be a space wherever it is appropriate, but at the beginning and end of the line, please don't give a space. Okay, that will end up giving the wrong answer. So another 2 more minutes before we move on to the next slide where you can enter the code. So in your answer, there should not be any extra spaces at the beginning or the end. All right. So, but there should be a space between two separate. I mean, wherever it is appropriate, right? So from the else block, if you see there is a space where it matters, but in other places there is no space. Okay. As far as the brackets are concerned, you can notice that so there is one mistake here that I have made. So you should not make a similar mistake. So for example, here, if is opening with a flower bracket, there is one, the second one is here. Okay. uh, the member is closing here, but there is nothing to close the if you notice, right? So this is actually one closing braces is missing. Okay, so please do not make that kind of a mistake in your answer. Okay, so if you have noted it down, we can move on another 10-20 seconds. We will move to the next slide. Okay, so I have got the sign to move on. We are going to move on now. Okay, the countdown starts. Okay, last 5 seconds. Okay, so see, that's the correct answer. Let's see. We have some. Okay, see, this is. See, someone has given the right answer here, but I said no extra spaces, but that doesn't mean that you should not give a space where it matters. And someone very unfortunately has made a spelling mistake here, even after getting the correct answer. So, some really unfortunate cases. There are some which appear to be wrong. See, again, here there is this additional space here. So I think most of you have got the correct answer, but see here this opening braces is missing. Okay, that's what I meant when I said be very careful about where you open and where you close. Right. So anyway, we'll move on and see how the leaderboard stands now. Okay, so we have only three who have retained their place, but I believe some of you have missed out even after you got the correct answer. So I think we'll try to fix that if there is a way, but don't. Yeah, so 4,000 is the number of points, right? Okay, so for those of you who, some of you seem to have some trouble with this, right? So we'll see what is really happening here. So see, what we want is that the first occurrence of each element has to be retained, all right, and all others need to be ignored if there are multiple elements. So for example, in this example list here, this one occurs twice. The three also occurs twice. So this last occurrence of one and three have they both of them have to be removed, right? So let's go through this procedure and see how it works. For those of you who attended this graded assignment session, we followed a method to visualize how recursion works, right? So this is called the traffic signal approach of recursion. So we have three colors: green, yellow, and red. Okay, green is used to color code the current call. So when you call the function using the list like this, what happens is that this is the current call being executed. So let's go in and see what happens. The length of L is not equal to 1, so we don't execute the base case. Okay. Now we are going to check if the last element in this list L is present in the init of L. Okay, so is 1 present in the first 4 elements? Yes, it is present. So this if block will evaluate, if condition will evaluate to true. So what we do is we go inside and we return a recursive call to the procedure, but with init of L. Okay, the last element is thrown out now because it is present in the first initial part of the list. We don't need to retain it because that is not going to be the first occurrence of one. So we are going to discard it and just compute on the initial part of the list. Okay, so now what this LO means is that this particular call has been suspended. Okay, so this particular call has been suspended, and we are now moving to the next recursive call, which is using these four elements. Okay, now we again go back. Length of L is not 1. Okay, so we are not going to execute this line. We are checking if the last element is present in the initial part of the list. Is 3 present in 1 comma 3 comma 5, the list containing 1 comma 3 comma 5? Yes, right? So again this evaluates to true. So we are going to return proc of init of L. So init of L now will be 1 comma 3 comma 5. Okay, so what we do is we once again suspend this call. This is the second call we are suspending, and we are going ahead and executing proc of 135. When you execute this, what happens? Again, the base case is not true. So we come to this. Is 5 present in 1 comma 3, list containing 1 comma 3, no, right? So this if condition evaluates to false, so therefore we enter the else part, right? Inside the else, what happens? We are we need to retain this last element, right? Because 5 is not present in 1 comma 3, that list. So this is the only occurrence of 5, at least so far. So we have to include that, and we go ahead and call the procedure on init of l, which is 1 comma 3. Okay, so now we go ahead and execute this. The same thing happens. 3 is not present in the list containing 1, so we go ahead and call proc of 1, right? So finally what happens, this list has one element, so this will evaluate to true. There are no other recursive calls, so I'll return the list as it is. I will return 1, okay, the list containing 1. And if you notice here, this will finally become red. Okay, so green means the call is current call is ongoing, yellow means the call has been suspended, red means we are complete, we are done with that particular call, right? We have nothing more to do with that, because that has returned the output. Now if you notice, we have to keep returning this all the way down, because we came up from this particular call. We'll have to go down, okay, one more step, one more step, until we finally enter the stage where we'll return 135. Okay, so maybe this was a bit fast. Is there anyone who did not understand this? You can post it. If you want me to go over it again, we can do that. Okay, I'll just wait for about 10 seconds. If you are all fine with it, then we'll move on to the next question. Okay, so yeah, I see quite a lot of thumbs up. Okay, so there is one question from Pritika. At the end, only one element. Okay, so at the end, by that do you mean see, the final return value is a list containing 3 elements, because uh, they are the unique ones. At the end, if by that you mean this call, if there is only one element, then you return the list as it is. Okay, so there, if there is just one element, you return it as it is. Okay, yeah. So since there are no other questions, we are going to move on. Right, so we are halfway through. It's 7 now. So 4, 5, 6, 7, 8, 9. So we have 6 more questions to go in the last 1 hour. Right, we'll have another 5 minutes starting now. If there are any doubts with this question, please post them in the chat. So please note that these are all arrows, directed arrows, right? So this is from 0 to 1. This is a bit small, so it may not be visible, but all arrows point downwards. So, Priyanka, the answer to this question, when I move on to the next slide, you'll have to enter your answer. I mean, it's a numerical answer, so there are no options. You have to enter one number. Could be it's one of the numbers that you see on the screen. That number you have to enter. Yeah. So please take your time. We'll have 2 more minutes. Okay. So another 30 seconds more, and then we'll be moving to the next slide where you can enter your answer. So please note down your whatever number you have obtained. Okay, I'm going to move on. Please have your answers ready. Okay, it's just one number that you have to enter. And time's up. Okay, so we have a wide range of answers. Correct answer is 0, but let's just look at, so 24 have given 0, 6, 9, 4 of them have given 10, some have given 8, 7, 12. Okay, point 1 is it's an innovative answer, but unfortunately that is wrong. So let's look at the leaderboard. Okay, we have 2 at the top and a lot of them tied for the second place. So Hariteja and Janani are right there at the top. So they've answered all 5 so far. That's good going. So let's now look at the solution. Right? Let's see what's happening. Okay, so this is again a recursive procedure, but it's kind of slightly different. There is no explicit base case that you can see here with an if condition and having a base case return statement inside it. Instead, the recursive call is inside a for loop, right? And outside you have another return that kind of acts like the base case of the recursion. So what is happening? Again, the traffic signal theory of recursion. That's what we are going to follow, right? So green means ongoing, and this is the first call. So you make your first call to the procedure proc of a comma 10, right, with 10. So let's go in and see what happens. We are looping through each row r in a. Okay, and if there is an edge from r to c, okay, then we are doing something, right? What does this mean? In this case c is 10. So if there is an edge from any node r to 10, then we are going to return the procedure, the same procedure called on a comma r. Okay, let's look at what that means here, right? The only edge from any node to 10 is 9 to 10, right? So 9 is the only node that has an edge. I mean, that 9 is the only node that connects to 10. 10 has no other neighbors, right? The only incoming edge is from 9. Okay, so a of 9 10 will be double equal to 1. That condition will evaluate to true. So we'll go ahead and return proc of a comma 9, right? So when we do that, we suspend 10, right? So note that it's yellow in both places, which means we are suspending that particular call. Then we are moving one step ahead and executing proc of a comma 9. Okay, now when we set c equal to 9, we are going to do the same thing. Is there any node r that has an edge coming into c, right? So r to c. So in this case r to 9, we notice that there is exactly one node 8. Okay, so now the call transfers to 8. So we suspend 9 and we move on to 8. Now the same thing happens here. C equal to 8 now. 0 is the 0 to 8 is the only connection that we have. So we are going to return proc of a comma 0. So we will suspend 8 and we'll move to 0. Now we are at proc of a comma 0, right? So let's see what is going to happen now, right? So we are going to loop through each r in a. There will be no node that has an edge from r to 0, right? So this is important. A of r0 will be 0 for every r, right? A of 0 1 is 1, a of 0 8 is 1, but a of r0 is going to be 0 for every node r. Okay, so there is going to be no recursive call. Instead, we are going to come out of the for each loop and we are going to return c. This case c is nothing but 0, so we will return 0, right? And when we return it without any recursive call, that means we are done with this particular call. Okay, so these both become red. Red means stop, right? So we now just have to come down from the way in which we came up, right? So we came up via 10 9 8 0. Now we'll have to drop down in the same fashion, 0 to 8, this particular call. Again the same 0 is going to be returned, and then to this proc of a comma 9, finally to proc of a comma 10. So that was the original call. We are at the ground floor where we return 0. Okay, so 0 is the answer to this question. Okay, now I have some questions in the chat. Yeah, so if it was an undirected graph, it would have been 1. A of ij and a of j will both be 1, but this is directed. So when do we need to come to the last line of code? See, the last line of code will come when you exhaust this for each, right? See, when will this for each be exhausted? It'll be exhausted only if uh, there is this return here, this return inside the for each never gets executed. Okay, so we'll come to this line only if we never happen to enter this if block at all. Only then we'll have to return C here. Now we will never execute the if block only when there are no incoming edges to a particular node C. In this case, zero is the one that satisfies that, right? There are no incoming edges to 0, right? So yeah, as Hussein has pointed out, if the incoming degree is 0, then we'll end up returning that particular node, and in this case that is 0, right? So I hope everyone has understood. Could you please explain why we are coming back to 10 again at the end of the computation? Okay. Yeah, I why we are coming back to 10. Okay, so see, uh, this is something that we discussed earlier also. You have to picture this as follows, right? So there are two intuitions. One, that, as I told, is this green, yellow, red. The other is the, you must treat recursion like climbing stairs or moving up a floor. So you enter at a particular point, let's say this you call the ground floor, and then you move up, you keep moving one floor up, right? When you reach the top, when you return something, right, you have suspended all these calls. You are not yet done with all of them, right? So see, a comma 8 is suspended, that is you have some unfinished business there. So you'll have to come down and return that value there, only then that call will get completed. So it has to pass from green, yellow, red, right? So until you get that red, until you actually return something, you are not done, right? So that is why you need to come back all the way up till 10, the first call. Okay, right. So I think we have spent quite some time. Let's move on to problem 5 now. Yeah, so Anupam, I think Arnab has answered your query. Case sensitive means capital and small, they are makes a difference. So do not make everything capital. That is not what we are asking. So whichever if the first letter alone should be in capital. So another minute maybe, and then I'll move on to the next slide. Okay, so please note down your answer. I am going to move to the next slide. Moving now. Okay, so the countdown has started. Okay, last 10 seconds. Anyone who wants to submit, please enter your responses. Okay, so the correct answer is true. Let's see. We have 25 correct responses. That's good. We have 6 which are false, and 2 which are not true or false. Okay, so how does the leaderboard look now? Okay, so the toppers have retained their lead. That's good to note. Very nice. Okay, all right. So for this particular question, see, this is a very interesting property. You might know this from your school days. So whenever you have the first n consecutive integers, right? If you keep adding the if you keep summing the first and last elements, right? You will get the same sum. So for example, 1 plus 5 is 6, 2 plus 4 is also 6, right? So no matter what the value of n is, if you keep selecting the first element and last element, and symmetrically if you keep going on, you will end up with the same sum, right? So this is something that was observed by the famous mathematician Gauss, right? So he observed it when he was a child, and once his teacher apparently asked him to keep the class quiet. She asked the fifth standard class to find the sum of the numbers from 1 to 100, and she thought that no one will be able to find the sum of so many numbers, right? So I mean, in fifth standard, you count using your fingers, right? But what this Gauss did was he noticed this very nice pattern, and he was very quickly able to find the answer, right? So I mean, this is a legend. We don't know if it is a true story or not, but essentially that's the idea here. So how do we do this? uh, what this code is essentially doing is it's checking if that property is true or not, right? I mean, it's so in this case it's always going to be true. So but anyway, let's go over it. So the sum here, as an example, it's going to be 6, right? So we are passing the first 5 integers, positive integers, and the number 6. Okay, so rest of init of L is going to return all the elements in the original list but for the first and last. So you throw away the first and last, you will return the intermediate numbers. So that is this. Okay, so since 1 plus 5 is double equal to 6, right, we are going to go ahead and return this particular value here. Now at this stage, what will happen is we will once again go and return rest of init of this particular list. That will be just that single element 3, list containing that single element 3. And at this stage, the base case of the recursion will kick in. So the length of L is now 1. Okay, so what will happen is you will end up true at that stage. So since there was no recursive call here, that particular procedure called terminated, so it returned true. This true will propagate all the way down. Okay, so that is the idea of the solution here. So I just have one question for you. So if I'm going to change this less than or equal to double equal to, will the code work? So okay, so we have Arnab posting that it's no. That's pretty good, right? So no, so it will not work for what n, odd n or even n. Some say it's odd n. So will the code work for odd n? Okay, so for odd n it will work. Yes, for even n it won't work. Right. So as Hariteja and many others have written, it will work for odd n. For even n it won't work. Right. So that's good. So you have a pretty deep understanding of recursion. That's good job, right? So unless anyone has any other questions, we are going to move on. 7, 8, 9. Last three problems coming up. Okay, so there's a question from Pritika. Return false, second last line. Return false. Yeah, so see what happens is, okay, what does it mean? So if this, see, your question is in some sense valid because here it's redundant. I mean, in this case, this return false will never kick in. But suppose you give some other kind of a list L, right? For example, I'll post it in the chat. If you give some random list, right? Say 0, 10, 20, 50, and so on, right? So if I post some list like this, what will happen is, uh, in that case, you will not have any other return value, right? So first plus last will not be equal to sum. In that case, you would not enter this if block, so you will have to go into the else part and return false. So it is for that reason that it's there, but again, it's kind of not very necessary here. Right, so could you explain why length of L double equal to 0 is wrong? Yeah, so as Hariteja has replied, right? So uh, if length of L is double equal to 0, when you get a list containing just one element, for example, when you get a list like this, right? You are going to what you are going to do is you are going to enter this line here. So first plus last is still defined, right? Because the list has just one element. So in the case of odd, it will work, right? So if it is odd, then it will work. But if it is even, what will happen is it will be okay. So just give me a second. Who asked this question? Okay, Agnibo Das. I think it's a good question. Just give me 1 minute to think over it. Okay, so yeah, I think you are right, Nibo. So I don't think you are wrong. I mean, I think L double equal to 0 will also work. That's a very good observation, right? But I would like to confirm that towards the end of the meeting. But I think that's a very good observation. See, for example, let's quickly go over this odd case and let's convince ourselves if it will work. See, when the list has just one element, what are you going to do? First of L plus last of L if you don't if you have length of L double equal to 0 here, then you will, when you call proc of list containing 3, first of L plus last of L will be 6, right? So 6 double equal to 6. So you will end up returning rest of init of list containing 3. Okay, so init of L will be the empty list, and rest of an empty list will also be an empty list. So in that case, you return 2. So for odd, clearly it works, right? So for odd, it works. For even, what happens? You have, say, 2 comma 1 comma 2 comma 3 comma 4. So you pass proc of 2 comma 3, right? Proc of 2 comma 3 will again work. Yeah, so I think it works. So that's a very good observation. So I think it should work for L double equal to 0 also, right? Yeah, so as Hariteja pointed out, for L double equal to 1, it will certainly not work, right? So for L double equal to 1, that odd even case will be a problem, right? It will work for odd n, but even it won't work. Okay, so there was one last question. It will work for odd n. Could you please explain once again, right? That for odd n. See, why, if it is double equal to 1, why will it not work for even case, right? So see, I will pass 1 2 3 4. Let's say I pass proc of 1 2 3 4 comma 5, right? So in that case, 1 plus 4 is double equal to 5. So I'll go ahead and execute proc of 2 comma 3. So when I execute proc of 2 comma 3, what will happen is, again, 2 plus 3 double equal to 5, so there is no issue. So rest of init of this 2 comma 3 is what? It's the empty list, right? So when I get the empty list, if length of L double equal to 1 is the base case, I will skip the base case. So I will come back and I'll try to access first of the empty list. So first of the empty list is not defined. So I'll get an error there, right? So that is why L double equal to 1 will not work for E1. If there are more questions about this, we'll get back to this at the end, okay? So in the interest of time, we will move on to problem 6. Yeah, so this is a return to the matrix, but we have to print a slightly different matrix now. Yeah, so we'll be moving quite fast on this. Maybe one more minute you have, and then we'll move on to the last 3 questions. Okay, so last 30 seconds and then we'll move on. Okay, so I'm going to move to the next slide. Please note down the option that you have. Okay, so there seems to be a lot of confusion between options 2 and 3. It was kind of unexpected. So let's go and see what has happened. Okay, all right. So the top two are keeping their lead steadily. It's good. So Janani and Hariteja. Okay, so let's see why that particular confusion is there. So create matrix, all this thing, all this is same, but this time instead of focusing on the column wise data, we are going to do it row wise, right? So we are going to go row by row, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rows are in some sense very important here. So a of 0, 0 is 1. Then notice that we need a of 1, 0 to be 1, right? So the row 1, column 0 should be 2, sorry, right? And then row 2, column 0, right? So a of 2, 0, that should be 3. Okay, so how will the code look like, right? So inner loop should be for the rows, right? Because we are going down the row first, right? Top to bottom first, and then we move from left to right, right? In the earlier question we moved first left to right and then we move top to bottom. In this case we want to move from top to bottom first, so that should be your innermost loop, right? So a of ij is equal to a of ij plus count. That remains, that part remains the same, but here the I will be for the rows, right? And it should not be for the columns. Okay, the column is the outer loop. Okay, so any confusions here? So a lot of you seem to have missed this and gone to the other one. If you have any issues, please post it in the chat. So why is 3 wrong? Okay, let's go back to option 3. See, option 3 is essentially the same as the first or second problem that you saw, right? So see, notice here I have just changed, I have changed this to columns, but and this to rows. But essentially, columns and rows of A both are going to return a list containing 0, 1, 2. Right. So whether this is columns and rows, that doesn't matter. What matters is what you put here. Right. So if you notice here, what will happen is you'll be incrementing I in the innermost loop. So you'll be moving right instead of moving down. You'll be moving right here. So it will give you 1, 2, 3, 4, 5, 6, 7, 8, 9 row wise. Whereas here in option 2, which is the correct option, the innermost loop is for I, right? And I happens to be the first index here. So you are moving down, right? So whenever the first index is incremented, you are moving down along the rows. Okay, so that is the reason we have this. So for those who got confused between 2 and 3, I think if you have one more look at it, you will be able to sort things out. Right. So in the interest of time, what we'll do is we will move on to problem number 7. Okay. 7 is there in front of you. If there are any questions, if you don't understand the problem, please let me know. Okay, so does anyone need more time or shall we move on? Okay, maybe so one more minute and then I'll be moving on to the next slide. Okay, so a lot of you seem to have completed it. So please note down your answers. I'm going to move in the next 10 seconds. Okay, changing the slide. Thirty seconds. Okay, let's last 5 seconds. Okay, so nearly equal number. No, a lot of people have given 1, 2, and 3. Okay, so let's see if our leaderboard has changed in any way. Okay, so the top two are not willing to let their lead go away. It's good, right? So we have now answered all 8 that seen so far correctly, the top two, and closely followed by some 5 others. Okay, so let's see what's happening here, right? So the inner for each is computing the degree of node R, right? So sum is initialized to 0 for every node R, and then we are going through each column, each C in columns of A, and we are, if there is an edge from R to C, then we are adding 1 to sum. So that way we are just doing nothing but counting the number of edges incident on R or the degree of node R, right? Since this is an undirected graph, you are in degree, out degree, there's only one degree, right? So uh, that is what is happening here. In this if condition, what we are checking is, does this particular node have a degree n minus 1, right? If it does not have a degree n minus 1, then this entire condition will evaluate to false. Sorry, this the whole if condition will evaluate to true, so we'll end up returning false. I'll just come again. If the sum is something other than n minus 1, this sum double equal to n minus 1 will evaluate to false. Since you have a not of that, the whole thing will evaluate to true, so we will return false, right? So yeah, the code returns false if the degree of at least one node is not equal to n minus 1, right? So even if you have a single node that does not have n minus 1 as the degree, this particular procedure is going to return false, which means the code will return true only if the degree of every node is equal to n minus 1, right? So Hariteja, so we are yeah, exactly, so we are checking if this graph is completely connected or if it's a click. So that's a very nice, very valid observation, right? So for example, we'll go over why each of these cases is incorrect, right? So in this case, notice that 0 has a degree 2. So there are 3 nodes, so we need the degree of every node to be 3 minus 1, right? 0 will work, but for 1 it won't work, right? Because 1 has degree 1 and not 2. So when will it return true? If the graph were something like this, it would have returned true, right? So the degree is 2 for every node. So in this case, it would have returned true. Okay. Why is this false? Because 1 and 3 here are not connected, right? So for 1, the degree is 2 and not 3. Remember, there are 4 nodes, so we wanted 4 minus 1 or 3. Since this 1 to 3 is not connected, we won't have a true in this case. So when will we have true for this particular version of the graph? When we connect 1 and 3. Okay, so I have a request for explaining this using code. So maybe I'll just come back to that. And finally, for this particular case, this will return false because we need a degree to be 4. There are 5 nodes, so we need the degree to be 4. When will that happen? When we make all these connections. So 1 to 3, 0 to 2, and then 4 should be connected to 0 and 1 as well, right? So yeah, Anupam Kumar, you are right. That's what I was coming to. So these are all called complete graphs, right? So where every node is connected to every other node. Okay, so this is a complete graph for 3 nodes. This is for 4, so it's called K4. This is called K3, and this is called K5. So that is a matter of notation, right? So I will return to Agni Boy, your doubt. I will return to that because we have 2 more questions. I would like to quickly complete them, right? Towards the end, maybe we'll take up the. But for now, I just want you to quickly go over this and do the last 2 questions. So again, since you have already seen this particular graph before, I am not going to spend a lot of time. Uh, there is a mistake here. This should probably go inside. Uh, so this opening braces corresponds to this if. So shall I move on? Can we move to the answer slide where you can enter your answer? Okay. So another 10 seconds. Please note down your answer. It's a numerical answer. So, okay, 1 minute. Okay. Just wait for 1 minute and then we'll move on. Okay, so shall I move on? I think it's about time. Okay, so please note down your answers. I'm going to change the slide now. You have to enter a number. Okay, pretty good. So we have many who have given 0. So about 16. We have other also answers also coming through. Okay, so now let's see the leaderboard. Are the top two still there at the top? Okay, the top two are still there, and the others also have retained more or less their positions. So that's good. Okay, so I have a rather mm, elaborate explanation for this. I'll have to shift to a new screen if I have to show you that. So what we will do is we will finish the last question in this particular session, and then we'll get back to why this is true. So for those who want a very quick explanation, what's happening here is nothing but the DFS starting from node 0, right? So so can someone tell me what is special about the way these nodes are numbered? Those who answered this correctly, this numbering of the nodes is deliberate. Can someone tell me what is special about the way these nodes are labeled? Why have I given? Okay, child number always greater than parent. Okay, that is correct. Okay, anyone else? Yeah, so yeah, DFS. So Pavan, yeah, DFS. But what about the DFS and this labeling? Exactly. So LB Gupta, that's the order. Yeah, Janani is finally right. So the nice thing is that this ordering I have labeled this particular graph, right? So I'll get back to this. For those of you who didn't get this, we will get quickly get back to this, but to the last problem also, so that we can see who finally is there on. So just problem because we don't have much time, so you need to answer this fast. Okay, so last 1 minute, please note down the value that you get. Okay, so I'm going to move to the next slide. I hope you all noted down your answers. Last 5 seconds. Time's up. Okay, so we have 15 as the correct answer. 14 of you have given that answer. That's good. 11 have given the answer to be 4. Okay, let's see the final position on the leaderboard. Okay, that's wonderful, right? So we have Janani and Hariteja have done a fabulous job. You have answered all 10, and others also. So Soumya, Ted, Hussein, I'm Sujit, and I'm not able to see the other name. I think it's Priyadarsh Singh, right? So you have answered 9. Then you have Sharayu with 8, Harsha and Harishankar with 7. So pretty good job, all of you. Wonderful job, right? So we'll move on. The answer to this question again very quickly. Okay, Anupam is 10. Okay, nice. All right. So I'll just tell you what's happening here. So for the what this is essentially doing is that this is removing the first occurrence of the element x in P, right? It's actually deleting the element x from the list P if it is present, okay? And if there are multiple occurrences of the element x, then what it will do is it will remove the first such occurrence. Now, why is that? The initially flag is true, so whenever the input x matches y, right, you will go inside and set flag to be false, right? And when you do that, notice that you are not going to add that particular y to q. From then on, note that flag is never updated, right? Flag remains false, right? So every other element you are going to add to q. Okay, every other element you are going to add to q, and finally you return q. All right, so that is why we have the answer as 15, because the first two will be removed. So you have 1 3 5 4 2. That's nothing but the sum of the first 5 positive integers, which is 15. Okay, so that is a bonus question from last week, and maybe when we share the slides with you, you can try it out. So that if ends the solution for problem 9, I'll quickly share the solution to problem 8. Okay, I will move to a different tab. right? So see what is happening in problem 8 is that it's a typical DFS from node 0, right? So you start from node 0 and then we move to node 1. Okay, we suspend the call at node 0. Then out of these two neighbors, 2 is smaller, so we move to node 2. Again, now we move to node 3 because it's smaller than 4. Okay, now notice that whenever this happens, we also keep updating the dictionary. So 0 is mapped to -1 to start with. 1 is now mapped to 0, right? 0 is the parent of 1. So if you had uh, looked at the week 9 graded assignment, this is exactly what is happening there as well as here. The parent of 2 is 1, parent of 3 is 2, and so on, right? Now, since at node 3 we have no more outgoing edges to explore, we return to 2, the call at 3 ends. Next we visit 4. Okay, we go back to 2, back to 1, and then we visit 5. From 5 we move to 6. 6 we go back to 5, and then to 7. Okay, so this is typically how it works, right? So yeah, so that kind of ends the you know uh, challenge session, unless and until you any of you has any questions. Maybe for 1 or 2 minutes we will take some questions. If not, I think this will non likelihood be the final challenge session for the CT course, right? So slides we will upload it very soon, right? So to the top two, a job well done. To the others, don't lose hope. These are, you can always improve. There is a lot of scope for improvement. So unless there are any other questions, we can go ahead and close the chat. Okay, so there is someone who wants to talk. Srinivasan, yes.
Not just in CT, but even in the previous sessions, I'm not been able to find out the challenge videos. Right, I see it for week 5, but after that, I have not been able to locate the recordings of the challenge session.
Okay, so we will get back to you on this, right? So we will update this from
Okay.
week 5. You're saying, right?
Week 6, I think, is there for some courses, but definitely week 7 and week 8, I don't think I could find them.
Okay, sure. We will update this.
Okay, thank you.
Yeah, sure. So Agnibo, the quick question, click question, right? So where is the click? Yeah, see what this in the click. What is happening is we are going through each R in rows of A, right? For each row R, we are setting sum to be 0, right? So this inner for each loop is going to find the degree of node R, right? If there is an edge from R to C, then we are going to add 1 to sum. So if, for example, for 0, there are two edges, right? 1 and 3. So the sum will be 2 for 0. Now we are checking if the sum is doubly equal to n minus 1. In this case, there are 5 nodes. So we want sum to be 5. Only then this condition will return true. Right? If it is not, then this not of false will return true, right? So not of false will be true. So I'll end up returning false in that case. Sum for every row, right? Not for every column. For every row, we are calculating what will be the sum of. See, for a given row R, we are going to calculate the sum of all the elements in that row, right? And that is nothing but the degree of that node R. Right, so that is how it works, and we want the degree to be 1 less than the number of nodes. Then and only then we are going to, if that is true for every such node, only then we'll return true. If even there is one node which does not have this particular degree, we are going to return false. Okay, right. So I think that is about it. We are going to close now. I hope you all enjoyed the session, right? So thanks for joining. So Vignesh, I think we can close the live stream now.
Sure, Karthi. I'll close it.
Thanks.
Thank you.
Yeah. Okay. So thanks a lot everyone for joining. We'll be closing the meeting very soon.